Good morning again, class. We are going over Unit 10's review. We are on problem 11. Problem 11 is identical to what we just did, except we're looking to see if these two triangles, triangle IJK, is congruent to HFG. So what we want to do is look at the ratio of these two triangles to determine if they're similar. So I'm going to do side IJ over JK is equal to HF over FG to see if the ratios are the same. So when I plug it in, we have 4 over 6 equals 6 over 9. Is that a true statement? When we reduce 4, 6, and we go 4 divided by 2, that equals 2. 6 divided by 2 is 3. And then we reduce 6/9, that gives us 2/3 and 2/3. So it is, these two sides are similar. But we're not done. We have to now look at this side is similar to this side, and this side similar to that side. So we're going to set it up as is JK over IK similar to FG over HG. So we have 6/5 over 9 over 7.5. When we do the math, 6 divided by 5 is 1.2. 9 divided by 7.5 is 1.2. Since the ratio of all of these sides of the triangles are the same, we can then write a congruency state or a similar statement that says triangle IJK is similar to triangle HFG, and it's because side, because all of the sides ratios of the triangles are similar. So that is problem 11. We are now going to be I'm going to skip over problem 12. I'm going to have you do that on your own because it's looking at a congruency statement. Problem 15 and 16 is identical to what we did in the last video clip. It's just setting up a proportion and solving for an unknown side. So I am going to do problem 18. It has to do with dilations, if it's an enlargement or reduction. And then I'm going to also do 21. 22 is similar to 21, and 19 is similar to 18. So I'm just going to do one example and then have you do the others. So let's look at number 18. Number 18 says determine whether dilation from A to B is an enlargement or a reduction. So I have this quadrilateral. So A, it looks like it goes through -2 to 6. And then it looks like it goes through -4 and then 6. And it looks like it does something like this. And like that. So this is A. And B, it looks like it goes through 2 and -1. And then it goes to -2, 2, just like that. And it goes like this. So this is B. So it wants to know whether a dilation from A to B is an enlargement or a reduction. Then find the scale factor of dilation. So the first thing you want to ask yourself, is it an enlargement or a reduction? When we look at A, is A the bigger shape or is B the bigger shape? When we look, A is the bigger quadrilateral and B is the smaller one. So we know it's going to be a reduction. Now we have to determine the scale factor. So what I like to do is look at corresponding points. So the first point for A that I'm looking at is at 6, 0. And then for B, that same corresponding point is at 2, 0. So in order to determine the reduction, we're going to go b over a and look at that point. So the b's value for the x value is at 2, and a's value was at 6. So 2 over 6, if we divide the numerator and the denominator by 2, that's going to give us 1/3. So it was a reduction of 1/3. And we can look at the other points. So if we look up here, it's at 0.6, and then it's at 0.2. Well, 2 over 6, again, is 1/3. So that's how you would do that. All right, so we are going to move on to problem 21. It says graph each figure and use its image under the given reflection. So this is a reflection. So I've already done these problems with reflection that I did earlier. Let me see if I actually graphed it. I believe I did. Yes, I did graph that where it was a reflection over the y-axis. So these two problems are the same that we did earlier. So I want you to do 21 and 22 on your own. And then also 25 is a translation. I know I did one of those. So you're just going to graph that triangle and then translate it -5 or 5 to the left and 4 vertically up. I'm going to do number 29 because we are doing a rotation. So the rotation is something that I haven't gone over in the unit review yet. So I'm going to do the rotation one for number 29. So let me do number 29. So I want to go to the page in the book that is going to help you for rotations. This is from page 909. So I want you to pay attention to page, I'm going to start using the green marker now. Pay attention to page 909. All right. I want to see if you can see that. It looks like you can. So page 909 has some key information about changing coordinates depending on if it's a 90-degree rotation, 180, or 270. So I'm going to do number 29 right now. Okay, so it has a triangle MNO, so triangle MNO, and it says that M's vertice is at -2, 2. N's vertice is at 0, -2. And O's vertice is at 1, 0. And then it wants you to rotate it about the origin 180 degrees. Okay, and so what I'm going to do is now graph these vertices. So I'm going to graph M at -2, 2, right here. And then I'm going to graph N at 0, -2. And O is at 1, 0. And I'm going to just draw a triangle. And now it wants us to rotate that 180 degrees. So it's very important to now go to page 909 in the textbook because it says for a 180-degree rotation, you're going to have new coordinates. Instead of being at x, y, your coordinates are now going to be -x, -y. So all we're going to do is for m prime, we're going to switch the signs. So if m is at negative 2, 2, we're going to have it at 2, negative 2. Since n is at 0, negative 2, 0, it doesn't matter if you multiply it by negative or positive, it's still 0, so we leave that. Since it's negative 2, we change the sign because it's going to be negative y. Negative times negative is a positive. So we have 0, 2. And then for O, we have 1, 0, so it's going to be negative 1, 0. And now we're just going to graph that. So m prime is going to be at 2, negative 2. So m prime is right there. N prime is at 0, 2. And O is at negative 1, 0. So O prime is right there. So I'm going to try to graph this with that black marker, even though it's kind of dying out on me. So after the rotation of 180 degrees, you're going to have the triangle looking like that. Okay, so it seems like green is a little challenging to see. So what I'm going to do is, I guess I'm going to have to use another marker next time. Let me just see if I can read that. All right, it is a little light. I'm going to write as dark as I can, but I'll keep going. And then replace the marker with another color. All right, so problem 30 is just like it. So look at page 909. So I am going to do problem 34. It's a composition of transformations, meaning we're going to do multiple steps. We're going to translate it, this line, and then we're going to reflect it across the x-axis. So let me erase problem 29, and then we will go from there. So problem 34 is, like I said, a composition of transformations. So it says that line GH has endpoints of G at negative 2, negative 3, and H is at 1, 1. And we're going to do a translation of 4 and 2. And then we're going to do a reflection over the x-axis. So the first thing I want to do is graph segment GH. So I'm going to create an x and y axis. All right, and we have G is at negative 2, negative 3. All right. And H is at 1, 1. The first thing we want to do is we're translating it 4 and 2. So what I want to do is we're going to have G prime. What we're going to do is take the coordinate negative 2. We're going to add 4 for the x value because we're translating it 4 units to the right. And then negative 3 for the y value. And we're going to add 2. So G prime's new coordinate is going to be at 2, negative 1. And then we're going to have H prime. We're going to do the same thing. We have 1 because that's our x value. We're adding 4 because that's what we're doing to x is we're moving it 4 units to the right. And then we're going to have 1 plus 2. So H prime is going to be at 5, 3. So now I'm going to graph that. G is going to be at 2, negative 1, G prime. And H prime is going to be at 5, 3. All right. But we are not finished. because we have to now reflect it over the x-axis. So what we're going to do is we have a line of reflection right here on the x-axis. So I'm kind of just drawing it right there. So what that means is G prime is at 2, -1. It's 1 away from the x-axis. So now we're going to move it 1 above the x-axis. So G double prime is going to be 1 above the x-axis at 2, 1. So this is G double prime. And if H is at 5, 3, it's going to be at 5, -3. So right about here. So H double prime is right there because it is 3 away, 1, 2, 3 from the x-axis. So then you go down 1, 2, 3. And so you just draw the line. And so our G double prime is just going to be a line that goes in that direction. So G double prime's location is going to be 2, 1, and H double prime's location is going to be at 5, -3. Notice how all we had for the x axis reflection, it changed vertically, which is the y. If we're at -1 here, 2, -1, it's going to go to 2, +1 for G double prime. And then same thing for H prime. If it's at 5, 3, it's going to turn into 5, -3 after the reflection. Okay, so that is number 34. Number 36 is just a easy reflection that you're just going to do. T is going to be reflected over L, and then it's going to be reflected over M. I know that you have done that before, so I'm going to let you do that on your own. I'm going to go over 37, and then I am going to let you do 39 on your own because it's the same type of problem. And then I'm going to continue on. So let's look at number 37. Let me erase this. So problem 37. Says state whether each figure appears to have line symmetry. Write yes or no. If so, copy the figure, draw lines of symmetry, and state their number. So 37, I know I'm not going to be able to draw it as accurately as possible, but it looks like it's that shape, and it does in fact have line symmetry. So if we look at the origin, so I'm going to put yes, there's line symmetry, and then basically what we're going to do is determine the number and then draw the line. So if we drew a line through here, there would be line symmetry. These two halves would be equal. If we drew a line vertically through there, these two halves would be equal. Again, if we drew a line right there, these two portions would be equal. And then if we drew a line right there and it went through that point, those two halves would be equal. So we have 1, 2, 3, 4. 4 lines of symmetry. All right. So number 43, I'll let you do on your own. It's a scale factor of an enlargement or reduction. You're just going to look at the proportions like we've been doing and determine if it is a reduction or an enlargement. Number 2 is where you're going to take a ruler. If you don't have a ruler, what you're going to do is just draw a reflection over line B. So we've done a problem like that already. So let me look at number 3. Number 3 is also a proportion. We've done that already. So you're just going to set it up as x over 21 equals 25 over 18, and then you're going to solve. It was like all of the other proportion problems that we did. Okay, so let me do number 8. And then after number 8, 10 and 11 is just transformations, which we've done in a reflection. 15 is a reflection. 15 is an enlargement or reduction, which you've done, and 16 the same thing. And then if we look at the other problems, they're also reflections. So I think I'm going to just finish off with doing, I'll do problem 3, and then we could do problem 8, and then that would allow you enough examples to work on the review and to work on it on your own. So let me just finish up with problem 3, and then I'll do problem 8, and then we will be done with the review. So the problems that I didn't go over, which is probably like 12 problems, they all are problems that you've done in the past. They're on my YouTube videos, plus I've done examples in the review to allow you to do them. So problem 3 has a triangle that has it looks like that. So I don't know why my Bluetooth turned off. Just give me a second. Okay, so we have another triangle. Looks like that. So we have these two triangles that I drew. We have a height of 18 for one, a height of 25 for the other, and 21 for this side and x for the other. So it wants us to solve for x. So we're just going to do a proportion. We're going to go x over 21 is equal to this height, 25 over 18. And then we're going to cross multiply, and we get 18x equals 21 times 25. Doing the math, 21 times 25 is 525. And then we're going to divide both sides by 18. So x is going to be 525 divided by 18. And that's going to be approximately 29.16. So it is approximately 29.16. All right, and lastly, I'm going to draw this shape for problem 8. Problem is it's a triangle prism, and it's 3-dimensional, and so I'm going to try to draw it as best as I can. So it looks something like that, and it wants to know if it has plane symmetry or axis symmetry, both or neither. So plane symmetry means if I drew a plane, like imagine having a flat sheet of paper going across, would I have equal portions? And if this triangular prism, if I was to cut it in half this way, the bottom with the base is not going to be the same as the top. And if I cut it in half, the drawing's a little off, but it also each of these faces are not equal, so it's not going to have plane symmetry. No plane symmetry. And then it asks if we have axis symmetry, meaning if I was to put a point in the very center and I was to rotate it 90 degrees, would it be the same figure as it is when it's stationary? And even though it's not going to be the same at 90 degrees, when I do rotate it at least 360 degrees in this direction, if I spin it 360 degrees, it is going to basically be the same image. You rotate it 360 degrees, and it's going to end up being in the same location. So it has, yes, axis symmetry. So that concludes the unit review. I'm going to post this on YouTube, and then I will see you in class. Have a great weekend, and stay safe.